Hello all, welcome today for today's video which we are going to discuss about graph. But before starting this session, let me all wish you a good Ganpati season. Now, what is a graph? A graph is a type of a data structure which is used for storing data and it is used for structuring the data too. But what does it make different from a tree? Tree is nothing but we use this data structure when the data is of the hierarchical manner, something like a parent-child relationship. But when you come to graph is used for structuring the data that are in non-hierarchical manner. That is, they doesn't have any parent-child, superior-posterior, such kind of relations. So, how would I define graph? Graph is nothing but set of vertices and set of edges. I'll be representing vertices as V subscript G and edges as E subscript G, where what is this G represents, I'll be representing the graph with the symbol G. So that is nothing but vertices of this graph G, edges of this graph G. And if I want to represent the graph with the help of a tuple is nothing but the ordered pairs. If I would like to represent the graph with the help of a tuple, so how would I represent, in the sense it is G, VG, EG, nothing but set of ordered pairs of the vertices and the edges. Let us see a very simple example of graph. Now, let us consider this as a graph. As you can see, the vertices are A, B, B, C, D, and E. And let us define the edges. What is an edge? A edge is nothing but the line that connects two vertices. So this is an edge. Similarly, this is an edge and this is an edge. So for clarity, we could name these each edges. Let me name the edges as E1, E2, E3, E4, E5 and E6. There is no rules in naming an edges. It can be of any way. So it's not strictly to follow in a clockwise or anti-clockwise direction. It can be random. We are just naming the edges. So if you see how would be the edges represented in the set EG, that is E1, E2, E3, E4, E5 and E6. If you kindly note this edge E1, E1 is actually between A and B. So what you can represent as AB. Same way, edge E2 is between BC and edge E3 is between CE. Point to be noted, it can be CE or EC. Since there is no direction, you can represent them in any order, but to be noted, it represents only one edge. You cannot include both CE and EC. It means that they are two different edges. So you can change the name, but don't include them with the two different names twice. Now, edge E4 is between BD and E5 is between ED and E6 is between AE. So either you can represent in this format or you can represent them in this format. That's all. This is the introduction of a graph. As you can see, we have seen one type of a graph that is nothing but undirected graph. As you can see, we have seen about one type of a graph that is nothing but the undirected graph. This is called as undirected graph. Since there is no direction, we are going to be called it as undirected graph. But if there is a to and fro direction, that is nothing but from where it starts and where it ends, we are going to call it as directed graph. Let us see that in the next section. Now let us see about some of the terminologies associated with the graph. First terminology is nothing but the directed graph. In the previous example, we have seen a graph where it is an undirected graph because there is no direction stated by the edges. As you can see over here, there is no direction from A to B. Thus, it states that it is an undirected graph, absence of direction. Now, what is a directed graph? Directed graph is nothing but it is an ordered pair of vertices. Now let me take an example of this directed graph. This is called as a directed graph. As you can see that there are directions. Example, you can see A. A has a direction to B. The edge E1 has a direction. The same way edge E2 has a direction from B to D. As the same way E3 has a direction from E to D. It is to be noted that E3 is not having a direction from D to E. It has direction from E to D. This is the difference between the directed graph and an undirected graph. Now, let us see some terminologies related to the directed graph. In degree and out degree. What is in degree? It is nothing but the number of edges terminating at a vertex. You can take any vertex. So let me take the vertex D. If you guys see at vertex D, here the vertex D has terminating edges. What is terminating edges? Nothing but the edge that ends at D. You can see two edges are ending at D. That is nothing but E3 and the nothing but E2. So now it becomes, that is the in degree, which is nothing but number of edges that are terminating at vertex. So if I take vertex D, the in degree of vertex D is going to be 2. Point to be noted, E6 is not terminating, it is starting from D. Therefore, we cannot count it as in the form of in degree. Now, what is out degree? Out degree is nothing but the number of edges that start from vertex is out degree. Again, the same example I'll take D. If you see from D, how many edges start from D? Nothing but only one edge, it is E6. Therefore, the out degree of the vertex D would be 1. You can calculate the in degree and out degree of any vertices in the graph. We'll see one more example of A. Let A be an vertex. So in this, if you see the in degree of A, what is an in degree? In degree is nothing but the number of edges terminating at A. So if you see there are no edges terminating, there are two edges leaving from A, therefore in degree becomes 0. Now the out degree is nothing but the number of edges starting from vertex A. So if you see from A, there are two edges starting. One is E5, the other is E6. Therefore, 2 is the out degree. The very simple thing how to understand this in degree and out degree is nothing but in. So in degree of vertex A, you just consider yourself as A and think who are all coming towards you, who are all coming towards your side, inward side. That becomes the in degree. So if you see at the vertex D, two vertices are approaching D. So therefore, we have seen D's in degree is 2. Out degree in the sense it's something like consider yourself as a vertex D and the edges that are leaving you, they are moving out of you. That becomes the out degree. So the out degree is nothing but only one edge leaves D. So therefore the out degree of D is 1. That's all. This is very simple to understand. Now let us consider the third terminology, that is source and sink. Now, what is source? In the name itself it exists that it is the source of an edge. So source of an edge is something like the edge starts from there. So consider a source. A source is something like any vertices where its out degree is 1 or more than 1 but in degree is 0. So source is out degree is 1 or more and in degree is 0. So in degree is nothing but what the edges that are coming towards the vertices. So if there are no edges coming towards the vertices, we are going to call that as source. And if there are going to be one or more edges leaving from the vertex, we are going to call it as source. Next is sink. Sink, as you can understand from the word sink, it just sinks. The edges just sinks. So which is nothing but a vertex has only in degree edges. Nothing but the in degree is 1 or greater than 1 and the out degree is 0. So now we will move on with an example. Source. Source here in this example it's going to be A. As you can see, A has 2 out degrees but it doesn't have any in degree. So actually A acts as a source for 2 edges. A acts as a source for 2 edges. Now what is a sink? Sink is nothing but the in degree is 1 or more but out degree is 0. So as you can see, B is an good example for sink. So there are 2 edges that sinks into B. So there are no edges leaving from B. So this is going to be called as sink. Therefore, B is sink. Now we'll discuss about the fourth terminology, adjacent vertices. 2 vertices are said to be adjacent. 2 vertices are said to be adjacent if they have a direct edge between them. So they should have a direct edge between them. So now in this graph, let us consider, is A and B adjacent? Yes, because there is a direct edge between them. Is B and D adjacent? Yes, there exists a direct edge between them. Is C and B adjacent? No, C and B are not adjacent. As you can see in the graph, C can approach to B with the help of D, but C doesn't have a direct edge to B. Therefore, C and B are not adjacent. Now let us move on with the fifth terminology, that is path. Again, it is very simple. Normal path, the path which we walk. So if there is a path, we will walk. If there is no path, we will not walk on that area. So when I have a path, when there are edges. So if I want to find out that there exists a path between 2 vertices, what should I do? I have to find the sequence of edges among the vertices. So I should consider the sequence of vertices, each adjacent to the next. So if you see in this example, whether there exists a path between A to E. So if you see if there exists a path between A to E, yes, there is a path. From A, I have to travel to C, that is nothing but with the help of edge 5. And from C, I have to travel to E with the help of the edge E4. And let us see one more example. Whether I can have a path between C to D. C to D, I can travel from C to E, and then E to D. So I am going to have two edges E4 and E3. But point to be noted, C to D has a direct edge E6. So either you can go through E6 or through E4, E3. What is the difference between traveling directly with the help of a direct edge and with the help of the intermediate edges? We will see in the further videos where we will be using the weights of every edges. Suppose it takes 6 rupees to travel from C to D, but it just takes 3 rupee to travel from C to E, E to D. Then which one is cheaper? C to E, E to D. So in that case, we will be using with the two edges. So all these concepts we will be see during the further videos of spanning tree. Now, let us move on with the sixth concept, which is very simple, length of path. So length of path, normally how we will be calculating in our real life with the help of meters, miles, kilometers. But how we will be calculating in this graph? In the graph we will be calculating the number of edges along the path. So as you can see, the path, that is the length of the path A, E is nothing but 2. Why? It involves two edges. Now, let us consider the length of C and D. So, if you consider this as a set, it's going to be 2, or if you consider this as a set, it's going to be 1. Very simple, isn't it? Let us move on with the seventh terminology, that is Hamiltonian path. What is an Hamiltonian path? Hamiltonian path is nothing but the same. It is a normal path. Whether we have to check there is a path between two vertices, but it should contain all the vertices in the graph. Now, let us consider an example. So if I need a path, so I can take many paths. A to B to C is a path. B to C to A is a path. C to A to B is a path. Many paths I can find it out. If you closely notice, these are Hamiltonian paths. So, this is a path that contains all vertices in the graph. So, you can see there are 3 vertices. Every path is having 3 vertices. Therefore, you can call it as a Hamiltonian path. Now, let us come to a very simple concept, that is loop. You must be knowing what is a loop from the programming languages. It is nothing but a set of statements that we will repeat again and again. Point to be noted in this diagram, in this graph, edge E4 is having same start vertex and same terminating vertex, which is nothing but what? It will be looping within this edge, within this vertices. So this edge E4 is going to be called as loop. So what is a loop? Loop is nothing but when they have the same starting vertex and same terminal vertex. Now, let us come to the concept of connected graph and unconnected graph. So let us consider now consider a graph G has vertices A, B, C, D and E. Got it? So it has 5 vertices. Let me take the graph in this manner. So A, B and C and D, E. If you ask me, is this connected graph? No. The graph has 5 vertices. Here if you see A, B, C are connected together. The other 2 vertices D, E are connected together, but this is not connected with this section. So it is unconnected graph. So what makes it as connected graph? There should be a connection between like this, where all the 5 vertices of this graph should be connected. Then we would be calling it as the connected graph. So there is one more concept called as the strongly connected graph. Strongly connected graph is nothing but there exists a path between each pair of vertices. So if you see in this section, there exists a path between A and A, B, C, and the same way path between B to D, path between A to D through B, and the path between B to E through D. So if you see, among any two vertices there exists a path. Therefore, we will be calling it as strongly connected vertices. Let us move on with the last terminology, multigraph. What is a multigraph? A multigraph is said to be a graph that contains multiple edges or loop. So if you see A to C, B to D, AB and CD and BC, so there are multiple paths, something like this. So something like this, there are two edges between A to C and a loop. So if this graph is having multiple edges among same set of vertices or a loop, then we are going to call it as a multigraph. That's all guys. It was a quite lengthy video. I hope so. There are many terminologies in graph, thus it took the time. So I hope that this video was useful. If you have any doubts, please comment. If you feel any suggestions, please free to comment it. Do not forget to like, subscribe and share. Knowledge is precious. Sharing is not a crime. Looking forward for positive responses. Thank you.